I'll get you guys to do a little quick introduction of yourselves.
Yeah, so I'm Ryan Harrell. I'm also known as Quad McFly. I ran for a long time mini quad test bench, did a ton of testing on ESCs. I've worked closely with Stefan and Akim, the developers of Blheli32, for many years on testing new releases. Going way back, I did testing for Pete on AM32 when it first came out. And I've spent a lot of effort to try to really understand what's happening with ESC firmware and how mechanically it's working and electrically it's working. So yeah, that's my background and connection to all of this.
And Pete?
Well, my name is Pete Smits, and I am, I guess, the creator of AM32, although it's been now touched by many hands apart from mine too. So but I will try to my best to sort of represent AM32 here and keep you up to date on what's happening and what's new with AM32, since a lot of things have changed in the past couple weeks.
The first thing I was kind of curious about, and I've been thinking about myself, is it challenging to upgrade an existing ESC from Blheli to AM32? And should we even be thinking like that? Because for the average user, that sounds like it's something that would be a little bit tricky. And is there some risk in doing that, like potentially, bricking your ESC or something like that?
My thoughts on it is that if you've got a ESC that's got Blheli32 on it and it's working perfectly fine, don't touch it. Just fly with it, enjoy it, use it forever. It's not going to just stop working because Blheli's no longer supporting it. But there's no guarantees that if you take an ESC that we've never seen, we've never worked on, and flash a generic firmware to it, that it's going to work better. So in my opinion, and then it sort of pushes the support burden onto, an open source project where there's a company that sold a CSC and made money on it. There's a company that wrote the firmware for it, made money on it, and then now we're doing the support for it for free. So I'd say if you've got a Blheli32 ESC, just keep it at that. Unless you're curious about trying AM32 and it's you want to flash it because you want to see what the characteristics are. But other than that, it's safest just to keep with what's working right now and not change it.
As far as the flashing goes, you can get inexpensive stuff online to do it, and it's not hard. I mean, I have to chuckle a little bit, right? Because when we got started in this hobby, Brian, we were taking old airplane ESCs, and I think I still have the programmer around here somewhere. Yeah, it's right here.
That's right. We all had to do that if you want.
So this thing that you had to hold on to the chip and hold your tongue right in order to get it to flash the original Blheli or Simon K.
Flight controllers we were doing, you're holding down the boot and you're like trying to get the boot thing going.
So I have to chuckle a little bit when people complain about flashing firmware, but it's actually not hard even to flash AM32. I have this old STM Nucleo dev board that has a ST link embedded in the top of it.
I see.
And so I just use that. I have the wires here connected. I was just flashing some ghost receivers over to ELRS last night with it.
That's what I use too. The same thing.
Yeah,
that looks like an.
So it's one of the cheapest ways to get an actual official ST link from ST Micro, because it's like $10 to $15 for a Nucleo board,
right?
And then you've got an ST link.
But it's an easy way to get into developing STM32 if you're interested. And like Pete said, it's like $10 to $15 depending on where you buy it.
Right.
So yeah, and as far as flashing goes, I've got this little guy here. That's an older T-Motor ESC that I flashed years ago to AM32, and it was not a difficult process. And just to test it out, when I was doing testing with Pete when AM32 was first being explored, and that was my test platform, and I still use it and still fly it on the latest versions of AM32. So it wasn't hard, and it's done great for me. So, but as Pete said, if it's working for you, and you care more about flying than testing things, then yeah, by all means, stay put. But I've always been one who cares more about testing things than flying. So
yeah. So right now, Blheli, you can't upgrade or the actual firmware, right? But you can still change the settings on your existing Blheli
Right.
ESC. Is there any concern that maybe that configurator will disappear at all in total? And
I don't think so, because it's a downloaded piece of software. Even if they pull it from their website, there's enough people who have it downloaded to their computers that it would get reposted. I mean, there's no way they could chase down that many takedown requests if they really wanted to get rid of it. It's just not practical. So I don't think they would even try.
I'm also really green when it comes to AM32, so I'm kind of the average user here. So I'm going to ask that kind of maybe the stupid questions. So I see, for example, that you can download a configurator, but there's also an ESC configurator that's typically used for BLHeli and BlueJ that also can flash AM32. Like, what's the difference between those, and when and why would I use one over the other?
So there's an AM32 config tool, which is just a small program that runs locally on your computer. So yeah, from the AM32 GitHub, you can find in the README, there'll be links to the config tools. So there's the download one is just a standalone tool. So you don't need any internet connection. It just runs off your computer locally. But just a little bit further down on that screen there, there's a Windows and Linux tool right there.
Yeah.
So you can download the offline tools there.
It's the same as Blheli32 config.
Okay.
Like, it's literally the same process. It's just you download the zip, extract it, run the exe file that's in the folder.
It's
and
right here, this circuit board connection.
Exactly.
Yeah. Okay.
And then the other option is to, of course, use one of the online tools, which use web serial. And that we have the option of the ESC configurator, which is the one you're on there too.
Right.
But we've actually started a website called AM32.ca. And AM32.ca has a link to downloads. It's got a configurator. It's got the bootloaders. It's got everything in one spot. So you don't have to search around for different sources.
Excellent.
So this will work similar to the ESC configurator.
Uh-huh.
So it's basically, it's an all one stop for everything there. So,
Nice.
and you can see in the download section at the top there, you should have all the links. And also there should be a link then to the offline tool through that one as well.
Okay.
But yeah, and that'll pull all the latest releases from GitHub. So as we update them there, they'll appear in the release folder on AM32.ca, and all the bootloaders are on there as well. So
what's the bootloader used for?
That's what you have to flash via the ST link in order to get the functionality to work with the other tools. So the other tools are not designed to work with the ST link. They're designed to work through that bootloader.
But I guess if you go from Blheli to AM32, there's no going back, right?
Right.
Yeah.
No going back.
So if I wanted to do some testing, say, and I had a test bed, bench tests of a Blheli ESC, and then I wanted to compare that to AM32, I'd go one way and then do the testing, and then Yeah,
or have the way I approached it when I was doing testing is I would use a 4-in-1 ESC. And I flashed one channel. This is for bench testing, obviously, not for in-flight testing. Yeah. But I flashed one channel with AM32 and left the second channel with Blheli32, and then I could just switch channels and test back to back.
That's a really cool way to do that. Yeah.
Yeah, you can't do that in flight, but if you're just running some bench tests to see performance-wise what the differences are, that's a good way of doing it back to back.
I've actually heard of a few people too who've had a ESC die on a 4-in-1, and they've replaced the MCU from a Blheli32 one just to a generic MCU, and then the only option is to flash AM32. And they've said it's actually the flight characteristics haven't actually changed that much, having 3 Blheli32 ESCs and 1 AM32. So it's an option too if you've got an ESC and you're and
it would actually be interesting to do that from a flight log perspective, because there are things you could learn from a flight log looking at the motor outputs and comparing like between the ones that have Blheli32 and AM32. Like that would do things in your flight log that you could actually interpret in terms RPM of data. Performance differences between the two.
Yeah, maybe like RPM data.
Yeah, exactly. And rate of change and acceleration data and stuff like that, that just, you would get weird kicks if the acceleration was extremely different between the two. So
are the parameters directly comparable? Like, so when we look at PWM, 24 kilohertz is 24 kilohertz, right? So those things are going to be pretty comparable. But what about things like ramp up power? Is that like, it seems that in Blheli the range goes from 5 up to like 400 or something, and in AM32, as I understand, it's a little bit of a different scaling. Or
We don't really have a ramp up power in AM32. So there is a startup power, and that sort of defines the minimum throttle level that's your base level that your throttle will start at. And that can give you a bit more of a kick to get your motor going by raising it. The ramp up itself is actually something that's done just behind the scenes. And it's based on the motor's kV. So the higher kV motors have a ramp up that goes to a higher RPM before it kicks off. The lower kV motors, the ramp up kicks off at a lower RPM. But it's the ramp up power, which is actually sort of a throttle restriction at lower RPMs, is wrapped up into that kV slider that's on the config tool. So that's something that we are actually we're going to be changing. We've got an experimental version where we've actually renamed that slider to be a bit more intuitive, where instead of you pick a kV on that slider, you select an RPM, and below that RPM, throttle is restricted, so that once it hits a certain RPM, the restrictions come off and it can allow 100% throttle, but it allows the throttle to basically be restricted at the very low RPM levels. And then as the RPM increases, the ramp, then the throttle that's allowed can get higher and higher. And so we're going to rename that slider ultimately so that it's not just AV related. But I was trying to make it easy. I was trying to just, you pick your kV and the ramp up will be good, but then there's so many variants out there. There's so many different props that people use, different types of motors, different battery levels, that it wasn't really the best way to go.
yeah, and even with the same kV motor at different stator sizes and different like magnet strengths, you're going to have very different RPM response compared to throttle. So yeah, I think that makes a lot of sense.
Yeah, and we've been telling people, to change. Like if they're a racer, for example, and they say that it's a little bit soft in the low end, we've been telling people, okay, well then take your kV slider and lower it down a little bit, the number in the kV slider. But that's not intuitive to pick a lower kV than your motor. But that's basically saying that the throttle restrictions are going to come off at a lower RPM by telling the config tool that the motor is a lower kV motor. So then it gets a bit more punch at lower RPMs. And if you want to soften it a bit so that it's a bit more, uses less current, especially during the first initial acceleration from low RPM to sort of mid RPM, then you can raise your kV slider a little bit more than your motor kV is. Right. But no, we will move that to a RPM based sort of absolute number. So you just pick the RPM that you want throttle restriction off at, and and that'll be a lot simpler for people, I think, to grasp anyway.
Yeah. So you guys are really pretty active in development too, right? Because I saw this post somewhere that someone said, well, AM32 wasn't developing very frequently, but then I thought Blheli32 hasn't really developed massively fast either.
Yeah, development is fairly slow. And it's the more targets we get and the more complexity we get, the slower it becomes to release a new version, because there's so much testing involved. And we sort of hit a point where we hit a little bit of a plateau sort of 6 months back that we've now sort of broken through, because we had all of our projects were separate GitHub repos at one point in time. So we had one for the Artery Tech MCUs, one for ST Micro STUs, one for Giga devices. And so we combined those all into one source, one build source. And that process took a long time. And at that point, it seemed to everybody that it just stopped. I mean, we were working on things full time to hopefully achieve the same result. So it didn't look like there's any progress happening because we were just trying to combine everything to make it easy for us to develop in the future.
Right.
Which we've now gone beyond that. So we're starting to add new features again now and starting to work on the function again because now we have all the sources in one place. And for some MCUs, there's even slight bits of regression when that happened too, which is really hard for people because I said, well, 1.99 maybe works better for me than this version 2 that you have, and they didn't. They're not aware of what's changed under the hood, which is quite a bit to try to combine all these projects together. So that was a bit of a process, but when it comes to, we spend a lot of hours on it, that's for sure. It's just progress is slow going. Sometimes, when we make a small change, there's so much testing that needs to be done, and we don't want to change something that'll improve one ESC, and then maybe that same change is going to make another ESC perform worse. So
yeah, good.
Yeah, there's it's tricky to. It's not like running writing Windows software on the computer where you can just iterate, see if it works, do it again. You iterate, then you test for sometimes hours, and then.
I think for most people too, it's like if it's working good, usually ESC firmware is not something that most people are thinking much about. So even Blheli has been like that. I remember it seemed like 32.7 was around for a long time before there was any change.
Yeah.
And nobody's batted an eye at it. And then, so I think that's expected that would, once it's stable and it's good, you just keep that going. Unlike, flight firmware, which also doesn't necessarily need to upgrade at the rate that's, for example, Betaflight upgrades. There's some risk in that really fast development too, where there's new bugs in that are introduced. So
yeah, well, that was always the Blheli guys. Their approach was, if it's working, don't mess with it. Like
exactly.
It was being involved in the development from Blheli through Blheli into Blheli32. Like a lot of it took often fairly significant pushing from the community for them to really say, okay, we're going to approach this. Like the push to go to, like, it took probably over a year of constant pressure for them to address the hardware PWM, which was the move from Blheli to Blheli. Like that was quite a bit of effort from the community to get them to address that, and they ended up doing it. But as Pete says, it took a lot of that time was probably testing hardware, right? I mean, like they have a significant amount of support that they've got to put into that. And then the same for the push to Blheli32, and then in Blheli32, the push for dynamic PWM and all of that took time and pressure from the community in every one of those instances for them to say, yeah, okay, we'll look into doing that. So, I think that's a universal truth across all of these firmwares. Like, if it's working, it takes a certain amount of momentum to say, okay, let's go ahead and push for some new features that might potentially, break some of the old features.
Yeah, exactly. I'm trying to think about what I've seen recently, but the amount of reports that they're pretty fragmented and small numbers of people saying things that are kind of vague too, right? So, but one of the things that comes up is the performance the same as Blheli? That's a common one. So
I did a bunch of testing for Pete fairly early on because he had that question. He's like, I'm developing this firmware. I mean, I'm sure Pete, you can fill in more on this, but you approached me saying, I'm developing this firmware and I don't really know how it stacks up. I'd like you to test it. So we ran a bunch of tests, kind of back-to-back tests looking at it. And there was not a significant difference in performance. If anything, AM32 had a slight edge on throttle linearity. But again, this was many, many versions ago, so it might be good to break out the test equipment and maybe do some more testing.
And this would have been mostly 5-inch rigs, which is the bulk of our hobby anyway. But as like myself and Josh and you as well are dealing with lots of lifters and that size thing. So have you much experience with AM32 on larger rigs?
I haven't, and that's actually what I'd like to start developing more. But right now, I don't expect it would actually work very well on 12S ESCs and lifters just because we've never developed on it. We're starting to get some hardware in here now, so we can start doing some testing. But really, until we get some ESCs on the bench and start spinning up some motors in an actual debug environment, then we can start working on these things. But it's one thing to build some 5-inch quads. It's another thing to start destroying $100 ESCs and $100 motors, en masse while trying to develop this stuff. So we're relying on some of the manufacturers now to give us some hardware to really play around with, because it's a very unforgiving process.
12S is not the most popular still, even in the lifter world though too. So I was more thinking like even the 6S lifters that were, I think there's about 3 or 4 ESCs that are almost universally used across 6S lifters. For example, the Hobby Wing 60 or 65 amp. There's the Foxeer Reaper and a couple like that. There's really just a handful of them that most people are using.
And Acon and T-Motor both have those big 8-channel ESCs. Yeah. It's really unfortunate timing for this because I know it's specifically in the research into the 12S part, because I wish Josh was here, but Josh had just been working with the Blheli32 devs to solve some of these desync issues we see on the big 12S rigs. And like all of that is just gone now. So you have to basically try to reconstruct it. And a lot of that was specific to Blheli32 firmware. It doesn't really translate to AM32 because of the behind the scenes, the way commutation is being handled is completely different between the two. So we're gonna have to restart some of that research process in a different firmware.
And the testing gets more expensive and also more dangerous. A 12S fire is a bigger fire, right?
Oh yeah, and even just spinning up a 12-inch prop close to you on a that size motor, when you've got with a debug environment, you've got to have everything plugged together and fairly close to you too. So
chicken wire and
pretty much. I'll make a plexiglass cage or something like that to hopefully protect myself. But right now, I just don't have that, and that's one of the things that we're going to set up so that we can start working on that. But we do need some help from the manufacturers when it comes to supplying us with equipment for that, because we don't have unlimited budgets, and we don't really make any money from this. A little bits come in here and there from donations, but it's right now we are still sort of relying on just our own out of pocket when it comes to buying.
Maybe time to start a Patreon and start advertising.
This is important. I'm going to take the time here. I want to stress that because. Let me just go and plug that. I'm going to plug your Patreon. So where's your Patreon? Where is
just you scroll down.
That's it there.
Right. Yeah. So, this would be a great place also to post some of your funny experiences, maybe some of those flames, and make an interesting video to share.
Yeah. Well, no, I should. Once I start doing some testing, I'll probably record everything because I like to do that, and then
So what I
flaming videos there.
I kind of shut down my testing a couple of years ago just because I couldn't keep the momentum going. And we were at a point where there wasn't a lot of forward development in motor and ESCs a couple of years ago. It kind of like you said, Blheli32's 0.7 hit, AM32 had just come out, and there wasn't a lot of forward movement at that point. So I kind of shut down testing, and I had people who were helping me, and they kind of ended up not being able to help anymore. So it was too much for me to handle at that point with my family and everything. So, but I'm at the point now, we just, I work at a university here locally, and we just started a 4-year engineering program at the university here. So I've been talking with them over the last couple of years as this was ramping up about the idea of restarting Mini Quad Test Bench as a university research arm. Getting students to run the testing and the technical sides of things, getting the data collected, entering the data, doing all of that, and reopening the analysis part of things. So this would be a great opportunity. I think I have some meetings scheduled later this summer with the engineering leadership team over there to try to get this rolling. But this could be super useful to get some third-party testing of some of this stuff, especially as we're getting maybe more into this larger stuff. And we have a wind tunnel at the university as well, so we could potentially do some dynamic testing. Looking at how do RPMs change under airflow, not just under static load, because static load has always been incomplete. It shows you one picture of what's happening under very high stress loading, but it's not necessarily an accurate picture of what's happening in the air under dynamic load. So it would be good to be able to get some testing going in that regard. So I'm fingers crossed that all those conversations go well and we can get some student-led research going on some of this stuff.
I'll put links in the description too of where to contact both of you guys.
Circling back to whether there's a difference between Blheli32 and AM32, there is. It's hard to really pin down exactly what that is, because I've run acceleration tests before too, and it seems like the curve is fairly similar. Sometimes AM32 is ahead. Sometimes Blheli32 is ahead, depending on the ESC, the motor, whatever. But, pilots, and especially the ones who are really, really, really in tune with their machines, can tell a difference. And
at least they think they can.
Yeah.
Well,
right? How do you account for that? It really takes blind testing and not, that's where it gets a little bit wonky, because there's always been those who swear that, this motor size feels better and all of that stuff. But then when you do back-to-back testing and you blind test it, they can't tell the difference. It's all in their head.
And the thing is, with really good bench testing, you can see subtleties that there's no way any human's going to detect it. So to me, that's we'll get at it with the bench testing for the most part with ESCs. I think it's very different from, say, is this flight controller firmware better for prop wash? Those kinds of questions are not so. I mean, prop wash can also be affected, I suppose, by ESC settings for sure. But
for sure,
again, that's I guess we need both.
I agree. We need both, but it's really hard to get the objective testing from the pilot level. It's really, really hard.
Oh yeah, absolutely.
But I think dynamic load testing, in a wind tunnel environment, is going to be really critical if we really want the full picture of what's going on in terms of the differences between, because again, static load testing is only one tiny slice of the performance window, right? That's just only one little piece of what's happening with the ESC and motor and prop and all of that stuff. Yeah. And getting really high resolution data at that level was important for a lot of things, and it helped us push forward ESC and motor development. When I was doing R&D for manufacturers back then, it really helped take us to that next step. But I think we can get even more if we move into a dynamic environment where we can test airflow and how everything performs relative to controlled intake speeds and controlled angle of attack and things like that. The idea would be to have a rig that could control the angle of the propeller relative to the airflow of the wind tunnel. So we have a rig where we mount the prop and motor inside, and then we can run a fixed speed of intake airflow. So we run up the wind tunnel to 20 kilometers an hour wind, and we run the prop through a full 180 degree rotation at every throttle point. So we create a matrix of performance running rate of change tests at 20 degree increments across 180 degrees. So into the wind flow and against the wind flow all the way through. And then you do that at 20 kilometer an hour, 40, 60, 80, 100 kilometers an hour. And then you start to get a multi-dimensional idea of what's actually changing as airflow changes and as wind speed changes and all of that stuff. And I think that's going to give us a much better picture of what's happening, in AM32 and in whatever firmware, BlueJ, the old Blheli, since that's still available, we can test across the range and get a picture of what's actually happening as we change ESC settings, as we do all of that stuff at a resolution that's much higher. And then you take that data, and that data informs what we're seeing from pilot response, right?
Right.
Because when a pilot says, "Oh, I feel this," then we can look at the actual data and say, here's the support for that, and
Yeah.
here's why. And
Yeah.
even when I was doing static load testing, there was a lot of that happening where a pilot would say, "Oh, I'm feeling this," and I could look at the static load data and say, "Well, here's what's happening, and here's why you're feeling this," and this helps us understand the physics of what's actually happening with the drone.
Yeah.
So I think it really takes both,
Yeah.
high resolution data and pilot experience together to really completely understand what's happening.
Yeah. Yeah. Is there? Can you test like reverse airflow and things that have?
Well, yeah, that's what you would do when the prop is in the opposite direction as the
Like
incoming
desync
airflow.
behavior and stuff like
Right.
that. Okay. Yeah.
Because that will be even heavier than static load, right? So if you've got 100 km/h wind flow in, and you're testing the prop completely 180 degrees to the intake,
Right.
you've essentially got the worst possible situation, and that would, in air, that would be the same as flying 100 km/h that direction, doing a 180-degree turn and punching full throttle in the opposite direction.
Yeah.
So that would simulate that environment.
Right. Right. So there's currently only, I think the only video I've seen is from Chris Razer on comparing AM32 and Blheli. Is there anything else out there that people can go to at this point, or is it something we just have to wait for, and we'll see more of that coming in the future, hopefully?
I do still have some comparative data in the Mini Quad Test Bench Data Explorer. You have to kind of dig for it.
Okay.
I believe it's called ESC response tests in the dropdown. But you can see AM32 versus Blheli32 in various settings and things like that.
So can people be, is it going to be like that we'll see T-Motor and all these great favorites that everybody loves? Are they all going to be now going towards AM32? And can we be confident that that's where it's going? And
Every manufacturer who's contacted us and is currently selling a product with Blheli32 on it intends to keep on selling that ESC. We will work with them to make a new target for AM32 for that ESC.
okay.
We're not going to start adding all the existing targets of
Right.
ESCs in the past. We're going to focus on ones that are currently being produced so that we can stay up to date, and we can provide manufacturers with at least a firmware that's working for their ESC. A lot of this we're doing blindly right now because we haven't seen the targets. So we'll just get a schematic and, here's MOSFETs, here's the schematic that we're using, make us a target. And that's tricky on us. So so we've got some hits and misses as we make some mistakes too.
Yeah.
But we are working with them, and the manufacturers, the good ones, are doing lots of testing on their own. So we send them a target, they go out and they fly it, they do bench testing, and they really make sure that it's put through its paces before it gets into the hands of customers. So, that's really the focus right now is to get the firmware out there into the hands of manufacturers so that they can actually start testing. And there will be mistakes and there will be issues, and we'll work through them. And we'll keep on trying to do little fixes and improve things until we have stable firmware for each of the currently released hardwares that are out there right now.
I have a question, Pete. Actually, this is something that has come up in multiple conversations online that I've seen. Specifically, this is about bootloaders. Is there going to be a common bootloader scheme, I guess, for the open source 32-bit options so that you don't have to basically go back and flash via the ST link? There's a common bootloader that can be used to flash multiple firmwares. And as a kind of side to that, would there ever be a way of using the Blheli32 bootloader to load AM32 or other open source softwares without having to flash? I know that was a question I've seen repeatedly asked. I know that right now, without having access to the details of how the Blheli32 bootloader works, that's challenging. But if, say, the Blheli32 devs were willing to work with you on that, is that something that could happen?
It's definitely technically possible. It would just take coordination between some of the devs, but we can replace So with the open source versions, we don't lock the MCUs. We don't write protect anything. We don't read out protect anything. So you can flash a payload, which basically replaces the bootloader with a bootloader from a different open source project. So we've made one for AM32 for updating the bootloader too, because normally the bootloader exists at the very beginning of the flash memory, and you can't really change it. But what we've done is made a payload which you flash like a regular firmware. Then that runs, it replaces the bootloader with new updated software. And then you reset the ESC, and then you can flash the main firmware again. And that can be used to go from one type of bootloader on an open source project to another one. With Blheli, because their bootloader is an encrypted upload, there's write protection, readout protection on the ESC. They would have to make a payload that sets those option bytes to make the ESC readable. I think that actually erases the memory when you do that on the ESC though too. So I don't know if it's really possible to go from Blheli32 to other ones, but they would need to actually make that. They would have to work with us so that we can upload a payload through the Blheli suite that will then replace their bootloader with one of ours. But
It does seem like
I don't see that happening.
it does seem like if they're going to choose to stop supporting the ESCs, it would be congenial to go ahead and do that, just for user experience wise, because messing with the ST link and all of that is kind of a more advanced approach. So from user experience wise, it would be nice to be able to just upload a custom payload through Blheli32 and let that open up the bootloader to flash other firmwares.
Yeah.
Can you flash an ESC that's not listed on one of your targets? Like, is there something we can look for on an ESC that I might have and just say, can I convert that to AM32? Would there, like, what?
Pretty much all of them will work. There's pretty much a target. We haven't really found any, as long as it's one of the supported microcontrollers.
Right.
There's actually only so many different hardware configurations for these. And the outputs are all the same because they are actually based on what peripherals are attached to the pins on the microcontroller. So every single one of the, say, for example, the FO51 MCUs, every single one of the ESCs that use those use the same ports and pins for the outputs to the MOSFETs. There's two different input pin choices. And that's really, so that's the choice between the bootloader. So there's two different bootloaders, one for that says PA2, one for PB4, and that's just what physically the MCU is connected to for the signal pin. So the signal pin has to match the ESC. And then there is 6 different options that are available for each ESC for the order of the comparators. And that is so that the ESC can commutate in the right sequence. And so we have all 6 hardware options available in each MCU. So we haven't found any that are impossible, that don't match any of the targets, as long as it's one of the MCUs that we are currently supporting.
I don't see the general population doing this too, though, right? So just to be clear, because I don't want to give the impression in this video that everybody should go out there and try to flash their BL32 to AM32. I don't think 90% of people are going to do that. So just to be clear, like, that's something that, and if you do it and something bad happens, it's on you.
Yeah.
But I mean,
we've got a good community of people to help you out too. So if there is anybody who's interested in flashing it, right, before you even start, take a picture of your ESC, go onto Discord, ask us or one of the guys, hey, can I flash a CSC? What steps do I need to do? And we'll point you to the right wiki and the right instructions for that MCU to flash it and tell you these targets are the most likely ones to work for it. So, but I would go on to the Discord and use the resources of the other guys who have flashed these to before embarking on that, before just blindly flashing things to ESCs too.
Boys, I gotta bring it to a close, but thank you again so much for agreeing to do this. I know you guys are both busy guys, and I appreciate your time and expertise. It's wonderful to have friends like you guys in this hobby, and I think we should. It'd be great to get Josh on maybe another time. I don't know if you'd be interested in doing this another time.
Oh, for sure.
A little more specific, maybe to the large motors and stuff.
Yeah, and that would be good because then we could start talking about some of the things that we, tested in terms of, the testing you did around the 12 ESCs, the desync issues that we're seeing, how we're solving those. So that might be a more specific session for that.
Yeah. Okay, guys. It's Sunday. It's early in the morning, and I'm sure you got lots of stuff to do yourselves as well. But it was a pleasure chatting with you guys.